Next quiz will be on a power of a matrix. This is still continuation of 5.2, but the method of diagonalization. And you have to do it this method, not the other way. So here's an example I want to work out with you. Just one example, you have seen a couple of them also in the homeworks and so on. So here is one more. I have the matrix 1, 0, 0, 9, negative 2, negative 6, negative 4, 0, 0. Okay. And I want you to calculate for me a to the power 5. And trust me, if you would have to do this by hand, it would get very ugly. So, step 1. Step 1. What? Something is making this jump. The characteristic equation. Okay, so we subtract lambda from the diagonal. Minus 6, minus 4, 0, minus lambda. Correct? Yes. Make sure that there are no mistakes here. Yeah. Okay, so again, we are a bit lucky here. Column. So column 2. If it's expanding in column 2, I have minus 2 minus lambda. So, and then what is left is 1 minus lambda, 0, negative 4 minus lambda. And if you multiply this out, we get minus 2 minus lambda. If you want, you can put a negative out. Then we have a 1 minus lambda times negative lambda, because there's no off diagonal. Okay, so if we put this equal to 0, this gives me lambda is negative 2, lambda is 1, and lambda is 0. So this is a case where we have actually 3 different eigenvalues, and where we know for sure that we can be able to diagonalize, okay? But just knowing that you can do it is not doing it, right? So we have to do it. Step 2. Eigenspace for lambda is, well, let's do negative 2 first. Okay, we have to replace, we subtract negative 2 from the diagonal. It means adding 2 to the diagonal, so we get 3, 0, 0, 9, 0, negative 6, and negative 4, 0, 2. Okay, luckily, with so many zeros, it's always good, right? So you can get rid of some of the bigger numbers by dividing the first row by 3. We can also do that by the second row, why not? Now, as I'm doing it, I do whatever I can, and then let's do the third row by 2. Minus a half, okay. So I get 1, 0, 0, divided by 3, so I get 3, 0, negative 2, and then negative 2 get 2, 0, negative 1. Okay, so we have our pivot, and we make the other two guys 0 by subtracting their one respectively 1 time and 2 times. No, 3 times and 2 times. Okay. So we get 1, 0, 0. So now we do it with negative 3. So we get 0, 0, negative 2. And then we do with negative 2. We get 0, 0, negative 1. We can divide row 2 by a half. We get 1, 0, 0, 0, 0, 1, 0, 0, negative 1. But of course, that last row you see immediately row 3 plus row 2 is going to disappear. And we get 1, 0, 0, 0, 0, 1, 0, 0, 0. Okay, fine. This gives us x1 and x3 are pivot variables, and then the free variable is x2. That's the free variable. So we write everything in terms of that free variable, and there should be only one, right? Everything matches what we're expecting. X1 is 0, x3 is 0, and x2 is equal to itself, so we get x2, 0, 1, 0. First basics factor. Okay, that's for lambda equals negative 2, lambda equals 1. So now we're subtracting 1 from the diagonal of our original matrix. Wait, I have it written here, so well, yeah, I hope you can see it, right? I'm going to subtract 1 from the diagonal now. Just double check if you. So I get 0, 0, 0, 9, minus 3, negative 6, and negative 4, 0, negative 1. That's the result of subtracting 1 from the diagonal. Okay, good. It's a little bit annoying here. We're gonna have to do fractions, I think. I don't see how to get a 1 without getting a fraction. I'm gonna do it in the second row. Well, first of all, we should move at least one of the rows up. So I'm gonna exchange row 1 with row 3. So I get minus 4, 0, negative 1. And I get 9, negative 3, negative 6, and then 0, 0, 0. Now I'm going to do row 3. Row 2 I can divide by 1/3, but it doesn't give me a 1. I need a 1, so I'm going to really force a fraction here by dividing by negative 4. So we get 1, 0, and now 1/4, right? We divide by negative 4. Here divide by 3, 3, negative 1, negative 2, and then the 0 row I'm not going to write anymore. Okay, we have this pivot. So we do row 2, minus 3 times row 1. This gives me 1, 0, 1/4. So I'm multiplying this with negative 3, so I get a 0 there, a negative 1. And minus 2, minus 3/4. That is minus 11/4. Okay, I put this on common denominator. Good. Oh, well, we're almost done because we only need to make sure that this is a 1. So I do row 2 minus row 2. Now what we get is 1, 0, 1/4, 0, 1, 11/4. Okay. The pivots first. These are my pivot variables, x1 and x2, and then x3 is the free variable, and so we get x1. x1 is equal to minus 1/4 x3. x2 is equal to minus 11/4 x, not x cubed, x3. Yeah, some people be careful that you write this. It's not a cube, right? And then x3 is just itself. So we get x3. So there's always indices, not subscripts, not superscripts. So minus 1/4, minus 11/4, and 1. Now I'm going to have to put this in a matrix, and I'm going to have to find the inverse of this matrix. So I don't want fractions. But at this stage, I have the ability to get rid of them by taking x3 equal to 4. And so the basis vector I'm going to get is minus 1, minus 11, 4. So this will be my basis vector. And then the last one was lambda equals 0, I suppose. Yes, lambda equals 0. So eigenspace lambda equals 0. And this is the original matrix, 1, 0, 0, 9, minus 2, negative 6. Negative 4, 0, 0. I have my 1 that I can use, so row 2 minus 9 times row 1, row 3 plus 4 times row 1. So 1, 0, 0. So I'm multiplying this with negative 9, so I get a 0 there, negative 2, negative 6. And now I'll multiply with 4 and add up, that is 0, 0, 0. And well, we're almost done. We just have to get a 1 here, so I'm going to row 2 minus a half row 2, and finish with 1, 0, 0, 0, 1, 3, and then the zeros I'm not writing anymore. So we have the two pivots, x1 and x2, and one free variable, x3. And that is, this tells me x1, x2, x3. This is the free variable. And so we get x1 is just 0, and this second equation tells me that x2 is equal to negative 3 times x3, and x3 is just itself. So if I factor out the next 3, I get a 0, negative 3, 1. Okay. And so we could always, of course, check that these are actually eigenvectors, right? For the right, that they do what they're supposed to be doing, okay? So I invite you to check this, that in this particular case, what should happen? Let's think about this. This was an eigenspace, the eigenvector for eigenspace, the lambda, for eigenvalue 0. That means that the image of the product rather of the matrix and this basis vector would actually be 0 times this vector to just a 0 vector. Okay, so what we call we're calculating the null space of this matrix. Okay, so I hope I didn't make any mistakes. So what we have is now P. So step 3, we can write down what P is and also what D is. I did the, let's keep the order in which I wrote it, negative 2, 1 and 0, right? So negative 2, 1 and 0, that's going to be my diagonal matrix. And then P is going to be consisting of the corresponding vectors. For negative 2, our basis vector was this guy. I didn't mark it, but that was it, right? Just double checking. Yes, negative 2, it was 0, 1, 0. We chose this one here to get rid of any fractions. And then the bottom, the last one is the one here that this one here. Okay. Step 4, we need the inverse of P. So that is 0, negative 1, 0, 1, 0, 0, 1, minus 11, minus 3, 0, 1, 0, 0, 4, 1, 0, 0, 1. We augment it with the identity matrix. We need a 1 in the top corner, so I'm going to replace row 1 and row 2 with row 2. Switch them, I mean. So I get 1, negative 11, negative 3, 0, 1, 0. And then I have 0, negative 1, 0, 1, 0, 0, 0, 4, 1, 0, 0, 1. I need, my first pivot is done with. This pivot, I need to, don't start to make the minus 11 equal to 0, because you're going to lose that if you're not in echelon form yet, which we aren't. So row 2, row 2, oh, minus row 2, right? Let's get rid of the negative sign here. So, okay, so I'm going to copy it. 1, minus 11, minus 3, 0, 1, 0, 0, 1, 0, minus 1, 0, 0, 0, 4, 1, 1. Okay, so now I can use this pivot to make the 4 below it 0, not above. That's for later. So row 3, minus 4 times row 2. So 1, minus 11, minus 3, 0, 1, 0, 0, 1, 0, minus 1, 0, 0. What I'm doing now is multiply this with negative 4 and add to the bottom. So that is 0, 0, 1. Negative 4, then that's 4, 0, and 1. Okay. Good, almost done. I need to get, now I start my second phase. I'm going to work down from the bottom pivot all the way to the top pivot, making sure zeros are above it. So we need to make a 0 here, so that is row 1, row 3, row 1 plus 3 times row 3. 1 minus 11, 0, so I'm multiplying this with 3 and adding up there, so that's going to give me a 12 here, a 1 and a 3. Okay, and then this one was already the right shape. Good, one more thing to do, and that is to get rid of this one now. Now we can do this, and so this is row 1 plus 11 times row 2. So multiplying this with 11, right? So I get 1, 0, 0. This 11, that's a 1, 1 and a 3, 0, 1, 0, negative 1, 0, 0, 0, 0, 1, 4, 0, 1. Okay, so this is my P inverse. I should double check. I want to, so check again, as I put this between parentheses, I'm not requiring you to do that, but if you have the time, and you have more time now, right? So you can always double check, right? That you don't make a silly mistake, which I constantly do. So I never trust myself. So this is P inverse. So what I'm calculating is P inverse times P. You can do, of course, P times P inverse. It's the same thing. P was 0, 1, 0. Make sure I minus 1, minus 11, 4. Minus 1, minus 11, 4. And 0, negative true, 1. 0, negative true, 1. Okay, let's see. Hopefully this works. This element is 0 plus 1 plus 0. That's already good. Minus 1, minus 11, plus 12. Wow, that's 0. That's nice. 0, minus 3, plus 3. Yep. That's, if you see this kind of cancellations that are kind of magic almost, then means you're on a good track, right? But it could always something wrong in the next one. So 0, 0, 0, that's correct. 1, 0, 0, that's correct, and that is 0. Okay, so the last one now, 0, 0, 0, right? And then it is negative 4 plus 4, yo, and that is 0, 0, 1. Yep, so it checks out. We're good. So where are we now? We know that D is equal to P inverse AP. Okay, I start from this formula, and from that formula I get the formula that A is equal to P dP inverse. Make sure that you don't get confused here where the inverses go, because that's important. Of course, it makes a totally different thing. Okay, so what was the question? The question was A to the power 5. Yeah, A to the power 5. So A to the power 5, we now know is P d to the power 5, P inverse. Okay, now what is d to the power 5? Let's look at d. Here is d, so I'm going to write it here, d to the 5. It's a diagonal, so I can take the power of each of the diagonal elements. Minus 2 to the power 5, well, 2 to the power 5 is 32, but with the negative, it's negative 32. And this is just 1, and then 0 to the power of 5 is of course 0. So this is d to the 5. Okay, so P, I'm copying P, this was P, and this plus P inverse. That's kind of why I wrote it also. So we have 0, 1, 0, minus 1, minus 11, 4, 0, negative 3, 1. That was P, right? This P has to come first, this one, right? Then we have d to the 5th, which was negative 32, 0, 0, 0, 1, 0, 0, 0, 0, right? Just scroll back, right? This is what we calculated here. And then P inverse, that was the guy on the left here, that was this guy. See, I can show you my laser pen now. And then we get 1, 1, 3, minus 1, 0, 0, 4, 0, 1. Okay, let's work this out. This is 0 minus, I'm going to multiply these two first. So 0 minus 1, 0, 1 minus 11, minus 3, 0, 4, 1. Okay, so minus 32 plus 0 plus 0, that's minus 32. Minus 32, 0, so minus 32. Minus 32 times 3, that is minus 96, plus 0 plus 0. Okay, that's the first row. Second row, 0 times negative 1, 0, so negative 1. Then I get 0 and 0, and the last one is all zeros, so 0, 0, 0. Okay, so big numbers, but not too many. Okay, so the final answer, we're going to get there, right? Let's count this element. 0 minus minus 1 is 1 plus 0, so that's a 1. Then I have 0, 0, 0. Then I get 0, 0, 0, so that was easy. Okay, this one. Minus 32 plus 11, that is plus 0. So minus 32 plus 11 is minus 21, correct? Yeah. Then I have the next one is minus 32 plus 0 plus 0, and that is minus 96. Okay. And then the last one, the last row, 0 minus 4 plus 0, so negative 4, 0, 0, 0, and 0, 0, 0. So that is the answer. Okay, and you can check this with, for instance, using Wolfram alpha. Perhaps I can show you, but again, I can show you how you can check your answer, right? So I have done this several times, but I'll do this here. Where is my? No, sorry, that's the wrong one here. Wolfram alpha here. Oh, sorry, I have to turn on my Wi-Fi. I didn't want it to get disturbed, so that's why it was off. Okay. Okay, so remember the input, the way that you input a matrix here was the inverse of a matrix that I asked. So that is by these parentheses, and you've put rows by row. So you see here, I cannot point with this one anymore, but you see that the 1, 0, 1, the first one, they are row by row, okay? So now what we need is not the inverse, so we can do away with this. In fact, let me do this way. Okay, so I want to do this to the power 5, so I can write here to the power 5, to the power 5. So let me show you this one. It's not the one that we want, but I'll show you that it does what we want to do. You see here it tells me, right? That's what it wants to do, and it says that. Oh, good check, right? So, but the matrix that we had was not that matrix, but the matrix, sorry, there was a, the first row was a 1, 0, 0, so that's the first row. This is the second row now I'm going to plug in. That was a 9, -2, -6, and then the last one was -4, 0, 0. Okay, and if you do something wrong, you forget a comma or something like that, it will let you know. So let me show you how what goes wrong. So there's a comma missing here, and he doesn't know what to do now. So you'll see, he comes up, oh, well, here, he tries to explain to me that what I did something completely wrong here. Okay, so now I put a comma there. We double check. This is the matrix we want there, right? It's to the 5th power, and this is what it says that it is. And let's double check with our answer here. What we had is, it sounds the same, right? If you can compare 1, 0, 0, -21, -32, 96, it's very small, but I can see it. It's correct. Great. Okay, that's it, guys. That's for the quiz.